So hello everybody, and welcome back. And I hope everyone enjoyed the three showcase sessions that we've just had running, and also maybe we're able to make some new contacts or to do a bit of networking during the short break that we've had as well. So yeah, I hope everyone did enjoy that. I know there were the three showcase sessions running alongside each other. So if you wanted to catch up on either of the two that you weren't able to follow, or of course if you wanted to recap on anything that you did watch, then as I said before, all of those have been recorded, and the videos, the recordings will be available immediately after the event. So you'll be sent a link out immediately following today's proceedings with the audio and video recordings for all of the sessions that have taken place. So next we move on to our next plenary session. So the next session we're going to be looking at is going to be focusing on technology and policy tools to increase spectrum efficiency. So we're going to be looking a bit more towards the future, looking at some of the options that are available, and yeah, discussing how they might be able to enable us to increase spectrum efficiency across different bands. So once again, we have a fantastic lineup of speakers ready to discuss these issues. So without further ado, I would like to now welcome to the stage our moderator for the session, Armand Moussi. Armand, welcome. So as I said, we've got a fantastic lineup of speakers here. So I will pass immediately over to yourself to introduce those, and yeah, looking forward to the discussion. So over to you.
Hey, thanks a lot, Dan. I'm delighted to be here. So many of you know me. My name is Armand Moussi. I'm the president of Summit Ridge Group. We do a lot of spectrum valuation work. And I'm delighted to be hosting session 4, which is technology and policy tools to increase spectrum efficiency. What does the future hold? We have a very distinguished group of panelists, starting with Chris Pearson, the president of 5G Americas, Ira Katz, the deputy chief of the FCC's Office of Engineering and Technology, Andrew Clegg, the global spectrum engineering lead at Google, Chris Murphy, the associate general counsel for regulatory affairs at Viasat, and Priscilla Argyris, public policy manager at Facebook. To start off our discussion today, Chris Pearson will give a few comments, and I believe he also has some slides. But actually, before Chris starts to speak, I'd like to just remind people that there is a poll that should be on the right side of your screen about asking people's prediction about which technology is likely to have the biggest impact on spectrum management in the next several years. So I encourage you to participate in that poll. With that said, Chris, are you ready to go?
Yes, I am. Thanks.
Okay.
All right. Well, thanks, everybody. Hello, everyone out there. Thanks for having me on this panel. It's a great event to be a part of, and I'm just going to provide some kind of overall introduction that might help our panel discussion about kind of where we are with 5G and where we're going real quickly. So next slide. One of the key items when you start to think about spectrum is all spectrum is not the same. And when we want to meet the real potential or the promise of 5G that we've heard about and the different types of applications and services, it'll be key for any government, whether it's the US government, Canadian government, Latin America, countries, everywhere in the world, to think about spectrum in a way that it actually will be the fuel for many of these use cases. Now, it's not the only fuel, but it is one of the key really lifelines for many of these types of applications. And it's not just going to be low spectrum. It's not going to be just mid-band. It's not just going to be high band. It's going to be the combination of using those, as well as technology, as well as even the policy tools that we'll all be talking about today. Next slide. So 2020, a year to remember. And when you start to think about 5G, the developments in 2020, I think our industry should be proud. There is so much going on in the world when you start to think about the COVID-19 pandemic. But there's also a great deal of progress that is happening throughout the industry when you start to think about the 5G development. And the reason I put this up here for the audience to think about is there are lots of aspects that are going on when it comes to 5G in 2020. And spectrum is one of the key areas as countries throughout the world are identifying, allocating, and auctioning spectrum. And this is happening even despite the pandemic. Things are being delayed in certain areas, but there are still a lot of progress being done, just like here in the United States. Next slide. And what does that progress look like as far as what's been done over the last few years as far as standards, spectrum, deployments? What that means today is we're at 115 global commercial rollouts. And this is based on the 3GPP standard 5G commercial deployment. So we are actually, as an industry, 5G is the fastest growing technology. Again, fastest growing mobile wireless technology in history. So we have been making progress despite the challenges that we've seen this year in 2020, and we expect that progress to continue. As an example, in the United States, by 2023, we expect at 5G Americas there'll be over 250 million 5G subscribers. Next slide, please. And worldwide, the forecast that we use with Omdia is that we would hit 1 billion subscribers by 2023. So this will continue, as you see, as it moves to 2025 to 3 billion. And LTE will still be a foundational technology, what I call the mobile wireless foundation for 5G, and that will continue. But 5G is taking off. We're starting to reach the promise, and we're really just, if you think about the baseball playoffs, we're really only in about the first or second inning of where we're going to be with 5G in a 9-inning baseball game. So with that, I'll turn it back to our moderator. And again, thank you so much for being here. I look forward to the discussion and the questions.
Hey, thank you, Chris. It was a great presentation. Next on our list is Ira Katz, Deputy Chief of the FCC's Office of Engineering and Technology, or OET. Ira?
Oh, thanks, Armand, and thanks. It's great to be participating in this conference again. I was going to say it's great to be here, but don't really know where here is anymore. So in thinking about this session and looking at the theme of tools to increase efficiency, start to think about, well, what tools are we talking about? And I start to think about the old saying, if all you have is a hammer, everything looks like a nail. And that's not the way to go about good spectrum management. So, so I think from the FCC standpoint, and the way I try to approach this is we need to always be flexible and kind of adapt to the situations as needed. I think, Chris, he mentioned that, all spectrum's not the same. And I think that's one of the really key points to keep in mind here is every situation is different and everything kind of has to be evaluated somewhat, by itself as we kind of look at where we go next and how we create more efficiency. So in thinking about it, efficiency can mean a lot of different things. From a purely technical sense, we often talk about bits per second, per hertz, per unit area, but I'm not sure that really is what we should be focusing on at the moment. I mean, we've got a lot of great engineers out in the industry who are, who are doing great work, and the technology is getting better. 5G is better than 4G. It's a little bit more efficient. We can put a little bit more a little bit more throughput. But I think those gains are somewhat incremental at this point. And I don't mean to downplay 5G, because I think there's a tremendous amount of utility and applications it's going to unleash. But it does somewhat depend on spectrum. In the U.S., we've made a lot of millimeter wave spectrum available, tremendous amounts of bandwidth that will get us a tremendous amount of throughput, high data rates, low latency. But we can also do 5G in the low and the mid bands, where you have some trade-offs on bandwidth and whatnot. So, but the thing I think we need to focus on, and I think where the commission has been focusing, is how do we enable more users in any given area? And by area, I mean both in spectrum space and geographic space. And this is the kind of thing we have been working on for years, probably starting in the first bit of kind of dynamic spectrum access we were looking at with white space, where we used a database approach, built on that, and we now have the CBRS up and running. We had a very successful auction for the protected access licensees just a couple months back, raised a couple $2 billion, and there's a tremendous amount of interest. I think we're seeing I think greater than 40,000 users at this point in a very short period of time. So that looks like it's going to be very successful and provide a lot of opportunities for spectrum usage. And the commission has also done a whole bunch of other things, looking at building on those types of spectrum access opportunities. So CBRS with the spectrum access system is a much more sophisticated system than white space. It's a full-on spectrum management tool in dynamic time, and I think that's something we really ought to look at as potentials to build on where it makes sense, in that there are always trade-offs you need to think about: exclusive spectrum versus shared, and licensed versus unlicensed versus licensed light, and make sure you, again, use the right tool for the right spectrum for the right job. So, in building on some of what we've done, we've recently adopted rules at 6 gigahertz to allow more flexible use of unlicensed, also using a database approach. This one's a little bit simpler than some of the others in what we're calling an automated frequency coordination. And then even thinking about our spectrum frontiers, our millimeter wave proceedings, at 28 gigahertz, we have geographic sharing between satellite and the terrestrial 5G networks. And we're able to take advantage of the fact that at those wavelengths, at those frequencies, the propagation isn't quite as good. So again, it's always this mixing and matching. And in closing here, I think we just kind of keep looking at what's the next thing. How do we build on these things that we developed, and how do we keep getting better? I think one of the things we're going to see is starting to integrate more artificial intelligence as those that gets better with things like the SAS and CBRS, and create even more efficient, better models. So with that, I will sign off for the next speaker and look forward to the Q&A later. Thank you.
Hey, thank you, Ira. So both Chris and Ira talked about the fact that not all spectrum is created the same, and there's different needs for different types of applications, which I think is an excellent lead into our next speaker, Chris Murphy, who's the Associate General Counsel for Regulatory Affairs at Viasat. Viasat is a satellite operator, so obviously their application is different. And I'd like to look forward to hearing what Chris has to say. Chris?
Thank you, Armand. It's a pleasure to be with everyone today. I'd like to discuss, as you said, a couple of points about satellite services, particularly advanced broadband satellite systems, how we use spectrum very efficiently. We are able to get and are building systems that will have terabit plus per second on some of our geostationary satellite systems. And also we're developing a LEO system that will have 27 terabits per second for the whole constellation of 288 satellites. On the flip side, which is, I think, the main topic of this panel, I'd also like to talk about the availability of spectrum today for 5G, and just what the situation is that at least we're seeing out there. To begin, I'd really like to make clear that satellite for a long time has been a very efficient user of spectrum, and that's only increasing. Advanced satellites are approaching, if for the engineers out there, Shannon's limit. So today's advanced satellites, their services and capabilities are made possible by increasing spectrum efficiency. That's exactly how we do it. Viasat in particular is focused on the Ka band. Access to adequate spectrum is now the limiting factor in extending satellite broadband networks to address the demand that we're seeing around the world. As we are building these systems, we've taken out all of the bottlenecks. So really the only thing that, similar to terrestrial networks, that we can add to fuel that growth is spectrum to meet the additional capacity and throughput that is being demanded. So for us, it's exactly the same issue. We're dependent on access to additional spectrum to serve more customers and provide more capacity. I'd like to remind everyone, it maybe gets lost a little bit, but satellites are also a heavily reused spectrum. So within networks and between networks, satellite operators coordinate, with other satellite operators, both nationally and internationally, to reuse the same spectrum many, many times. And through both orbital locations, if you're geostationary, you can have the same spectrum used at adjacent orbital slots, or between GSO and NGSO. So through angular separation, we're able to reuse the same spectrum even between those different types of orbital configurations. Viasat, as I said earlier, is building satellites that are capable of terabit plus throughput. So that means much more higher download speeds and also much more capacity, allowing us to serve many more people with higher speeds. And part of the development of those geostationary networks is small beam technology. So that allowed us both to dynamically move capacity during, very short periods of time, minutes, when the demand changes within beams, and also focus it much more widely depending on what the demand scenario is. So if we get around an airport or a port or some sort of terrestrial hub, we can focus our capacity around those locations. But if we're also getting demand from a larger area, we can adjust to that as well. And then temporally during the day, as capacity demands during peak hours switch, we can dynamically move the spectrum and the capacity that it allows across geographic areas. In addition to that, Viasat, like others, is developing a LEO constellation of 288 satellites. That will have, each satellite will have 96 gigabits per second of throughput, and that will collectively enable the 288 satellite constellation to have 27 terabits of connectivity. Now, on the flip side, which is the lead-in, I think, to the discussion today, I would make a little bit different assertion than maybe some of the others. I would say that 5G has plenty of spectrum, and we need to look at how it is deployed to make sure that other services are taken into account, existing users, and so that there's a full ecosystem of networks available for consumers today. As most of the folks here probably know, the WRC 19 last year allocated over 17 gigahertz of millimeter wave spectrum for 5G in the 26 gigahertz band, 37 to 43, 45 to 47, 47 to 48, and 66 to 71 gigahertz. So that's over 17 gigahertz of millimeter wave spectrum. I would think that should be plenty to allow for lots of 5G growth over the next decade or more. In addition to that, the conference also put on the agenda for WRC 23 more spectrum in the low and mid bands. So that's now being studied for 5G, and that will be a decision that will be taken in 2023. At the national level, many countries are holding auctions for 5G in the low, mid, and high bands all over the world. So the reality is that there's plenty of spectrum out there for 5G today and for well into the future that's being deployed. And I would challenge the premise that we have a spectrum crunch for 5G at the moment. Sorry. However, if that's not enough, I'd also suggest that refarming 2G, 3G, and 4G spectrum is important. For example, LS Telecom did a study last year where they looked at the estimates for IG that the ITU had done for 5G spectrum demand in 2020, and what has actually been licensed is about a third globally of what is available. So the point of that is that national regulators need to actually license what's already being globally harmonized. So if that happens, that immediately makes available more of the spectrum that has been globally harmonized. This is in the 700 megahertz bands, 2300 megahertz, 2600, and others. So there's what LS Telecom study found was that there was 570 megahertz of terrestrial spectrum that hasn't even been licensed since, but has been harmonized but not licensed domestically since 2015. So there's lots of opportunity there to for more access to spectrum that is fertile. The other thing that I think is important is from another services perspective is that when there's an open question about whether 5G receivers, the actual equipment that's being built, is being designed to account for the existing spectrum neighborhood in which they're deploying. It's our position that policymakers need to ensure that 5G operators are developing their equipment with characteristics that do make them compatible with existing services, particularly in adjacent bands, so that there's no wasted spectrum. When new services deploy, they can use all the spectrum available to them and be a good neighbor. And so that allows certainty for 5G deployment, but also certainty for existing services who need their spectrum, both for existing services and to, customers, and to be able to grow. And it provides a predictable, certain environment in which to innovate. So I think we support and use all technologies at Viasat. We believe a very efficient spectrum user, and have been working on innovative technology along with the rest of the industry for many years to efficiently use the spectrum, and welcome others to come in as well. But we think that making sure that we're efficient with what we have and what people are using today is a critical component for making sure that spectrum's available for everybody. So with that, I'll thank you for the opportunity to share my comments and look forward to the panel.
Hey, thank you, Chris. Now we'll return from our detour in space and come back to Earth. Our final two panelists are from Google and Facebook, which you may not think of as being telecom operators, but they're obviously in the business of distributing content and have both have done a lot of work on some very interesting last mile solutions and have come up with some creative ideas. Our next speaker will be Andrew Clegg, the Global Spectrum Engineering Lead from Google, and we're going to hear his perspective on spectrum efficiency. And Andrew?
All right, thanks Armand, appreciate the introduction, and Dan, thank you as well for hosting the 9th American Spectrum Management Conference. I think I've been to 8 out of the 9. I was on vacation one of the years and missed it, but it's always a great conference, so thanks for putting this on. So I won't say too many remarks here because I look forward to getting in on the discussion and the audience questions, which are the best part. But I will say, the perspective I'm coming at is Google has been very heavily involved in deployment of CBRS and the 3.55 to 3.7 gigahertz band in the US. We're also very active now in developing 6 gigahertz technology for shared use of unlicensed devices. In that band, we're looking very closely at 3.45 to 3.55, and we have a number of other initiatives on the table. And we've learned in this process an awful lot about what makes spectrum sharing work and where we can make it better, both from a technical perspective and from a policy perspective. CBRS in particular is the most recent deployed implementation of shared spectrum. It has been very successful so far. So we began initial commercial deployment late last year. We were approved for full commercial deployment early this year, and despite the pandemic, in the meantime, we, as the CBRS industry in total, we're now at tens of thousands of deployed base stations nationwide. And then, the number of users is in, 100,000 or more because you've got, tens per base station. The most interesting statistic, though, is the number of reports of interference to incumbent users since we have deployed those tens of thousands base stations, and that is 0. There have been no reports of interference to incumbent operators in the entire, basically 10 or 11 months that CBRS has been in operation. To me, that means we've engineered the system well. We're doing a good job protecting the incumbents. And in fact, I would argue we're doing too good of a job protecting incumbents. The fact that there's been no interference reports means that we're obviously not right up against the margin for interference. And I think there's several reasons for that, and we can discuss that as part of the discussion coming up or the audience questions. But CBRS has been a great experience. And has done very well, raised $4.5 billion for the PAL auction that just concluded on August 25th. But despite the success of CBRS, we've learned a tremendous amount from CBRS. We've learned what we can, where we could tweak the implementation a little bit to make shared spectrum better. And we've also learned what components of CBRS are working very well. And we certainly look forward to applying the lessons learned there. We're already applying the lessons learned as we develop the 6 gigahertz infrastructure. And we're also looking at applying some of the things we've learned about shared spectrum into other spectrum, 3.45 to 3.55 as one, perhaps below 3.45, and other upcoming bands. And we sort of look forward to using the experience that we've gained and improving those deployments as we move forward. So I'm going to stop there because, like I said, I like to get to the discussion and the questions, and maybe we'll have some lively discussion with the rest of the panelists. So thank you very much, Armand. Back to you.
Thank you, Andrew. Our next speaker is Priscilla Argyris, Public Policy Manager at Facebook. I believe Priscilla also has some slides.
So I took a different tack and just wanted to present one issue that we're focused on at Facebook related to spectrum efficiency. It's a little bit more specific than this broader conversation. But we are focusing on how enhancing spectrum efficiency can enhance connectivity in rural areas. And, in rural areas, there's a lot of connectivity challenges, whether it's just a difficult environment or low population density, minimal existing infrastructure investment, or CapEx constraints. In a lot of those situations, we have found that there may be licensed spectrum that's lying fallow and it's going unused in those areas. And because these challenges are about investment rather than competition, we think that policymakers can promote frameworks that allow this spectrum to be shared, and that's a new opportunity to connect rural areas. And so policymakers can tap the potential of this unused spectrum by allowing multiple operators to either pool resources or allow lower cost providers to come in, and a lot of times they're locally based to provide service. Next slide. This is just showing what the opportunity is in LATAM, where there's more than 60 million people that either are uncovered or at 2G or at a slower speed. Next slide. So one type of these frameworks is what we call network as a service, or NAS. And in a NAS framework, both the access network and the local backhaul is financed, deployed, owned, and operated by a neutral third party that then provides service to the MNOs. Next slide. So when you look at NAS as a rural connectivity solution, it's a wholesale model that allows the MNOs to compete for customers without network expenses. And this shared network lowers the total CapEx, enabling network expansion beyond the existing MNO's coverage footprint. Local operators can then focus on their rural connectivity in the rural communities and can deploy and operate at lower cost for everyone. And you can see in this picture, this is a NAS deployment with a satellite partner. So I think it's a framework that's technology neutral, depending on what's the best technology for that area. Because at Facebook, we believe that it's going to take a mix of different types of technologies to actually bring connectivity and faster internet to everybody. So part of, overall, when we're thinking about these frameworks and how to use spectrum sharing and rural connectivity, I think there's two key points. And one is that it should overall promote a cooperative sharing with the licensee and the service provider, benefiting everybody, and also provide a certain amount of certainty to those that are going to go ahead and build infrastructure in terms of how long they'll be able to access the spectrum, and that it's going to be an overall long-term sustainable solution. So I look forward to discussing the broader issues with the rest of the panel. That's all I've got. Thanks.
Armand, you're on mute.
Thank you, Priscilla. I've just gotten the results of the poll in terms of which applications of technology will have the biggest impact on spectrum management in the next 5 years. Spectrum efficiency was 17%, receiver performance 10%, licensing 10%, and sharing of spectrum or dynamic allocation a whopping 63%, which I think leads into maybe a first question to sort of get the panel going. And that is, it's been, I think, 8 years since the PCAST report of 2012, a report that was actually initiated by a lot of non-traditional folks in the industry, including a number of people from Silicon Valley, which advocated extensive spectrum sharing as a way to massively increase capacity. Now we are here 8 years later, and I think the biggest example we have of that is CBRS. We see greater spectrum sharing, do you think, going forward, or is this going to take off more aggressively, or is this going to take another 8 years, 10 years? What does the future hold with respect to increased spectrum sharing implementation?
So maybe I'll jump in first. So I think, again, it somewhat depends. As I said earlier, I don't think there's any one-size-fits-all solution, but I do think we are seeing attitudes towards spectrum sharing change and approaches change. I think a prime example is the recent action that the Commission took at 3.45 to 3.55 gigahertz. This is where the 100 megahertz below CBRS that is largely occupied by federal government DoD operations, and the federal government, basically looked for ways to make spectrum available for commercial operators to use that spectrum, mostly, in most places across the U.S. at full power levels, with just a few caveats that they need to use it when and where they have critical operations, mission critical type deployments. So, I think, even just a few short years ago, that might have been unheard of. And I think a lot of credit for this goes to the success of CBRS, that, some of the elements that go into successful sharing is building trust. I think that might be one of the most critical. And I think that the level of back and forth between the commercial operators, the SaaS operators, and the federal government operations, DoD operations, in getting to the point of getting that deployed, built up enough level of trust that they could go the next step to a next band and make more spectrum available, which benefits the country as a whole. So, so I think those are the type of things that we might be seeing more of in the future as we keep looking for more opportunities to get more folks using spectrum in more places.
And I think we should just always, I would just say we shouldn't always just kind of default to this idea of a CBRS model necessarily, because the comparisons, CBRS has successful auctions we just saw, and we have 100,000. I think that was mentioned by one of the panelists, maybe 100,000 users. But we're kind of comparing that to ourselves versus looking at, well, what's that spectrum doing in other countries of the world? And typically it's been allocated as exclusive use licensed spectrum, and there's millions of users using it. So it just kind of depends on. I mean, I think our outlook has to be look for innovative ways to make the best use of spectrum, and that could be sharing, or it could be looking for more efficiency within the government that has a very large amount of spectrum. So I don't think it should be a one size fits all. Like, hey, we should sharing is sharing is the answer, because it could be the answer in some cases, but it might not be the best solution for the country or the treasury or even the users in the long term as we compete against the rest of the world.
Yeah, and I would just add, I agree. Even being a CBRS proponent, I would agree that not every aspect of CBRS should be applied to every shared use band. I think there are certain aspects of it that fit. There are certain aspects that could be applied to 3.45, but may not be appropriate for all of the aspects of CBRS. With regard to the users and the deployments, we've got, like I mentioned, tens of thousands of base stations. We're a little hampered by the pandemic. A big use case for CBRS was enterprise and office environments and shopping malls and things like that. And that obviously that's going to be an issue for quite some time before we get back up to deploying large scale in those types of environments. So I think we'll see a rapid increase in CBRS uptake over time. But the other thing that we have to keep in mind is we're comparing what we're deploying here in the US to what's being deployed for 5G and 3 gigahertz in other countries. And in most other countries, this band is clear spectrum, pretty much uninhibited. In our country, we have enormous complexity in the band. We have the DoD in the band. We have an enormous number of fixed satellite service dishes in the adjacent band we need to deal with. The DoD is classified. We can't know about their operations, and so we have to detect and avoid. So we have a complexity in 3 gigahertz that we don't have in other countries. And I think we'll work through those complexities. We're seeing it in the 3.45 to 3.55. We're working through those complexities, which is good. And I also would say that because of our experience with CBRS, and we're not, we wouldn't treat every band as like a CBRS nail. But I think there are certain aspects that we can learn from CBRS and the other bands. And I think that will cause the deployments to go and the development to be even faster. Like in 6 gigahertz, we're already applying some of the lessons learned in CBRS. And I think in 3.45 to 3.55, to the extent that any CBRS-like concepts are exported there, I think we're learning quite a bit about how to speed up the deployment and implementation.
Armand, if I could jump in as well. I think
you have something to say on this, Chris?
I tend to agree with Chris here. I think every service does need its own core spectrum in order to be able to invest and innovate. And so, Within that spectrum, as I said earlier, the satellite industry reuses between operators through coordination, through spacing of angular spacing and also orbital spacing, spectrum many times. So there are different ways of looking at how efficient spectrum use is achieved, but I think every service needs to have some sort of certainty about what its spectrum access is going to be in order to innovate. So I would definitely make sure that that core spectrum is available so that people can make investments that are sometimes very long term.
I also just wanted to add, I think earlier we were talking about how CBRS is just a really sophisticated framework that's addressing a very US specific point, and that even in the US, like in 6 gigahertz, we have the AFC model, which is a little bit different. And so it's just really important to take into account the specific circumstances and where a specific country is. And I wanted to point out that Ofcom in 38242 has actually just decided to establish a shared band where they're doing simple coordination to allow sharing, and that they're going, especially as you look around the world, the US is, first of its kind model and ready to take on this really complicated spectrum management, but that might not be possible in other places. So I think just taking into account the specific band and the specific circumstances in a country and what it's capable of to actually get that spectrum used by more people, more use cases.
Okay, so we have a question from an audience member. What key regulatory tools should regulators focus on to improve spectrum efficiency and connectivity? A fairly broad question. I know, Priscilla, you alluded to an idea that I've read before, kind of use it or share it, about potentially people being able to use licensed spectrum if it's not being used. Is that something you'd add to that list?
I think, that's one tool. Also, if you have a mobile, if you have build out requirements in rural areas, making them flexible enough so that you could have this type of a third party come in and establish this shared resource or shared network as a service that other operators could come in and use, and just try to create a framework where the regulator can maybe be a neutral arbiter, but really allow the parties to have the incentives to come together and work together cooperatively for a long-term sustainable solution for rural areas.
There are comments about essentially key tools that regulators should employ to try to squeeze the most out of what we have?
Yeah, I'll jump in again, Armand. I think that regulators need to make sure that equipment's being built to efficiently use the spectrum that's available, that spectrum that has been used for other purposes in the past by operators is refarmed to the extent that it's not being used for those services anymore. And also that when spectrum becomes available, it actually gets licensed and put on the market in a timely way so that operators can get access to the spectrum quickly, and then we can see what in the marketplace works and what doesn't.
The only thing I would add is
I think all those are good points, but again, I think it still comes down to one size does not fit all. All situations, and in some cases it makes sense to refarm. In some cases, it makes sense, to repurpose spectrum, to relocate users. And and again, if you look up and down the spectrum, and over time, I think the options certainly have changed for a number of reasons. One is the spectrum overall is definitely a lot more intensely used today than it was 5 years, 10, 15, 20 years ago. So there are more users, more systems to contend with. But we've also gotten better, the technology is better, and the tools we have to work with them are better, whether it be databases or whether it be finding ways to relocate. And even if that means relocation, meaning a change in technology, these are all things that I think are on the table that we just can consider as we examine each band in and of itself. Because again, as we've said over and over, not all spectrum is created equal. There are different propagation characteristics, different atmospheric characteristics due to rain or other weather effects, and so on and so forth. So you really need to kind of look at each situation as not necessarily in a vacuum, but on its own, and then what can you learn from past actions to build on successes we've had and make things better and get more efficient down the road with regardless of the service and the mix.
Yeah, and I would just add on this is I agree with Ira, and one of the things is though to make sure that we paint a bigger picture of a broader landscape of federal agencies and NTI working with them to understand, what generation of technology was the spectrum that you're using? Are you using it? Or how are you using it? And what equipment are you using it? There's a lot of areas that are probably classified, we're not able to understand. But when you start to think about like the mobile wireless industry or even unlicensed industry, but mobile wireless, we're in our 5th generation of technology, and every 10 years we're actually moving to a new generation with really new equipment, new technology, new innovation, and that makes better use of our spectrum. Can we be using tools within the government and NTIA to basically see how we're using spectrum better and for what purpose? And then try to think again, the bigger picture, the bigger landscape of, well, what could we do then? What are the possibilities given this information? Or if we move forward in technology in some of these federal systems, could we pack it differently? Could we use spectrum more efficiently? Could we change things around?
Okay, so this the bulk of this conversation has essentially assumed a spectrum constraint and desire for more spectrum in one way or another. I'm wondering if we can look at this from a very big picture. How is the U.S. doing relative to the rest of the world in terms of providing spectrum for 5G? Ira, do you want to?
So, well,
some context as to, we always complain the FCC is not moving fast enough. So,
well, yeah. So, I don't know if I completely agree with that. The FCC is not moving fast enough. I mean, we certainly are.
It's a general complaint, so I just let you.
We're certainly global leaders at millimeter wave. We were first there, but we had a lot of availability. As I think it was Andy said, or maybe it was Chris. With mid-band spectrum, where a lot of the rest of the world kind of acted in the 3 gigahertz band, we have a lot of encumbrances, and we needed to look for other ways to make spectrum available. But so CBRS was one way to do that for that particular spectrum. But on the heels of that, the commissions acted very quickly, I think, in trying to clear spectrum up in the C-band, the lower C-band, and repurposing 280 megahertz there. And then now moving on the 100 megahertz below, we have things happening at 2.5 gigahertz. Commission just adopted a notice of proposed rulemaking, or report and order, right, at 4.9 gigahertz. Looking at a new type of a leasing model. So I think the commission is taking a very flexible approach at looking at all these bands and freeing spectrum up as quickly as possible, within the constraints we have. And I think compared to past spectrum issues that I've dealt with, we're moving at light speed on between C-band and 3.45. As fast as I've ever seen us move on almost any spectrum issue.
Yeah, I'd like to add to that, and I never thought I would say this, but I think to some extent the FCC might be moving a little too fast. I swear I would have never thought I'd say anything like that. In 3.45 to 3.55, for example, moving very, very fast, they have further notice proposed rulemaking on the table to open that up. But there are DoD encumbrances there. We know from the CBRS experience that those DoD encumbrances, number one, can be very impactful. And number two, what happened in some aspects of CBRS is we were sort of surprised at the last minute by encumbrances that the DoD hadn't let us know about originally. And those were very unpleasant surprises. We worked out with the help of FCC and NTIA and DoD. We've worked through those successfully. But there is this aspect of, surprise encumbrances from the DoD that you weren't aware of to start with, and those need to be worked out very carefully. We want to be very careful. We have limited amount of maneuverability in 3 gigahertz because of these vast encumbrances by the DoD. We have the 3.45 to 3.55, which can apparently be cleared a fair amount for commercial deployment. The further notice tees up the 3.35 to 3.45, which is an additional 100 megahertz below that. I maintain that we really need to understand the encumbrances issue as a whole for all that 200 megahertz, if that's eventually going to be available, before we move towards deployment, because we may end up actually hampering ourselves if we're not fully aware of what the impacts of the continuing DoD operations are on those bands before we start adopting service rules. There's also another concern that hasn't been addressed, and that is the potential that clearing out some of the DoD activity in 3.45 to 3.55 or 3.35 to 3.45 might push some of that activity into the CBRS band. And we're very concerned about that. That hasn't really been addressed. So, we've got kind of limited maneuverability in the band, and I think it's important we understand the big puzzle before we start adopting service rules.
Armand, if I could add something, I would say that we need to make sure, again, that I'm sorry, I think the question is not whether we're in a race just to allocate spectrum for the sake of a race, or whether we're doing it for some kind of demand. And I would argue that I think others have here, the FCC's done a very good job of, and I used to work there. Ira and I worked on spectrum issues long ago at the FCC. And in comparison to, 20 years ago, the commission is moving at light speed, and I would say well ahead of demand at the moment. And other regulators around the world, similarly, if there's a demand, then I think they're doing their best to try and meet it. But we shouldn't just be allocating spectrum for so people can wave around how many gigahertz they've made available for service. It has to be connected to the demand.
So I'd say I think the FCC has been making great progress, and I agree with Ira. We are a leader. We are a leader, and we're a leader. We continue to be a leader in the millimeter wave and what we've made, and then the strides that we've made in midband are significant because we have more challenges than most other countries around the world. But those other countries are continuing to bring out. I mean, they see what can happen when they put 5G in the marketplace, and we're really, again, in the first or second inning of the applications and services. So they understand the demand that's around the corner to help their economies, to help their technology leadership. So, but I think the FCC should be commended for looking now at the midband, and as well as NTIA now studying it, looking at in the Department of Defense, because the midband provides that sweet spot of both, capacity and coverage. But when it comes to the FCC, I think they're making really good progress, as Ira said, with the C-band, the 3.45, the 3.55, the millimeter wave. So we just got to kind of keep this momentum so that we can really meet that full promise of 5G.
Okay.
Yeah, and I also want to add, though, that I agree with Chris. We shouldn't be making spectrum available just for availability's sake. But on the other hand, one of the things we try to do is look at the projections, and we've all seen the projections of where the demand curves are going, the number of devices as the IoT is coming on board, and machine to machine, and so on and so forth. And one of the criticisms the commission has had in the past is we're too slow to act, and then we're always behind. And I think the commission, we're looking and trying to be as proactive as we can based on looking at what the coming demand is projected to be in order to make sure that those resources are available to the private sector, when they need it, rather than them needing it and then we're trying to play catch up. I mean, it's almost, unfortunately, it's almost a no-win situation. We act and you get criticized. You don't act, you get criticized. But I think we're better off trying to do the best we can based on the projections, the way we see everything moving, to make sure those resources are in place as early as possible, because we can always change course if needed. But it's harder to get going. It's much easier to keep that inertia moving and act within as we're seeing things develop.
And we know how long it takes, right? We know how long it takes to get spectrum identified and then finally allocated and then auctioned. It takes a long time. So I think the momentum is good, and that I agree with Ira's comments. We need to keep it moving.
So we had a question from the audience. Someone asked if we could explain the use it or share it model. Priscilla, do you want to take that, or do you want me to?
Sure. I think it could be used in different ways. I'll just say that our preference from Facebook has been to focus on models where you're building a cooperative relationship with the licensee. And I think someone else asked a question about, how would a third-party neutral provider work in a rural area versus an urban area? And I think, we all know that shared infrastructure is helpful. We have shared towers, but in a rural area, that active sharing is also helpful. When competition's not the issue, but investment's the issue. And so it really just matters kind of what the regulator has set out in terms of incentives. And if the regulator has created mobile build-out obligations, that can have the same impact as a use it or share it, in terms of giving those licensees the incentive to try to make sure service is getting there. And a lot of times you do have some type of operator provider that might not have access to spectrum, but would be willing to create a business model that actually works for them locally in that rural area. So addressing those questions a little bit. The other model that I can think of is in the UK, where they said that you could apply directly to Ofcom to get access to spectrum in rural areas, but they do try to create a cooperative arrangement with the licensee. So that's the information I have about it. I don't know if anyone else has any comments.
So Armand, can I explain exactly how it works in CBRS as a very specific, concrete model? So the way use it or share it works in CBRS specifically is a priority access licensee can buy a license for a license area, and the license areas are based on counties. The spectrum access systems that manage the deployments in the band know exactly where the priority access licensee has deployed their base stations in the county. And the spectrum access system can compute a service area around that base station based on the power that it's running and its antenna pattern and things like that. And to the extent that other parts of the county aren't being used by that priority access licensee, so they haven't deployed a base station or anything in other parts of the county, the lower tier, the general authorized access, is allowed to be authorized to use those portions as long as they don't exceed a certain interference threshold into the area that is being served by a priority access licensee. So basically, you have a license area, but if you haven't deployed a base station in certain parts of that license area, the lower tier is allowed to go in and use that unused area until the time that you decide that you're going to deploy there. So that's how user share works in CBRS.
I think the term was originally coined by Michael Calabrese around 2011 in a paper that he wrote that is available on SSRN. Just Google use it or share it, and Calabrese, and then you'll find like a 35-page paper that talks about his vision of that back then. Okay, so Chris, I wanted to sort of chat about if there's any issues with respect to 5G and satellite, particularly interoperability with terrestrial systems, given some of the low latency requirements.
Sure. Thanks, Armand. That's a good question. Satellite has been has digitized much earlier than other networks, and also pushing content to the edge of networks, developing what are now SD-WAN or software-defined wide area networks that take multiple networks and combine them for the best of different aspects. So I think satellite has for a long time been sort of on the cutting edge of developing those networks that are really making a difference in terms of connectivity for users at an affordable cost. So really through innovation and necessity, we've been able to push the edges of those new technologies by combining these networks. So in many respects, network slicing, pushing content to the edge, we've already been doing what the core aspects of 5G are today. And as we work with those networks to be interoperable in the future, we are already there in terms of the principles for 5G.
So you're not going to have any problems if someone calls and their call is routed through a Viasat satellite because it's in some rural area and has to go through a 5G network, and the latency is more than 150 milliseconds or something like that, and it times out. You're not going to have those kind of issues.
Well, we already provide service to thousands of customers in the United States, voice service today without any problem. And we've been qualified by the FCC for universal service funding as a result of that. But as I said, we're looking at all kinds of different techniques for routing traffic. And that may be one of them. It will work, but we may use multiple networks as well. So we're experimenting and deploying today in the commercial market networks that combine all these aspects. So no, I don't see that being a problem.
Okay, one question for you, and then I'll also like to hear other people's view on this. You'd indicated that we're approaching Shannon's limit, and there's not much more room to add capacity without getting more spectrum. However, over the last 10 years, the satellite industry, to a certain extent led by Viasat, has dramatically increased the amount of capacity it can get through a geostationary satellite by creating spot beams of smaller and smaller sizes. Are you saying that sort of technology has the ability to have more and more spot beams has essentially reached its limit?
No, I think
it's cellular too, right? Can't we just keep breaking down the size of these territories around a base station?
Absolutely, and that's what you're seeing with small cell technology. Right. It's no different in the satellite industry. We're now capable of building satellites that have many, many hundreds of small beams, and you're going to see, I think, that continue to proliferate. Also, connecting to high-quality fiber and getting rid of any bottlenecks that are in the network. Those things are only increasing the capacity. As you said, the one limitation is the amount of spectrum we have to be able to now transmit that data. So yes, I think although we're now reaching Shannon's limit in terms of spectrum efficiency on satellites and their use, and the only thing we can do is add more spectrum, the actual hardware itself will actually exponentially in the next generation of satellites increase even further the capabilities of what the satellite can process at any single second.
There was I guess I'll ask the same thing for everybody else. There was a rather low response with respect to, actually no one, very, very low response with respect to any kinds of thoughts of dividing cell sites in terms of increasing efficiency. Anyone have any thoughts on where that's headed and to what extent we're going to see more of that if we're really having so much trouble pulling spectrum away from the DoD, and we're also, the wireless industry's done a good job of getting spectrum from the satellite industry on one side, the TV industry on the other side, and trying to pull some from the DoD, and you run out. Are we going to see more cell splitting, or does that become cost ineffective? We've gone as far as we can in that route. Silence.
Well, I mean, to some extent, again, going back to CBRS, that was part of the point of the CBRS band. It necessarily limited the power limits fairly low, not just for coexistence with DoD, but also because the concept of the band was cell splitting and providing throughput where it's needed without building out, supercells and stuff. We've done a lot of propagation work that shows that within the clutter layer of a typical city, you're getting 40 or 50 dB of additional loss over what the propagation models are telling you because of the clutter. And this is actually a good thing. This provides tremendous reuse, provides a high density of data on the ground, and provides that high spectrum efficiency that you're looking for. Again, as long as you're within the clutter layer. If you're above the clutter layer, propagation is considerably better. And while I'm on that point, I would like to bring up, the topic of this panel was, partly technology that can improve spectrum sharing and spectrum efficiency. One of the things I want to make sure we touch on is, development of better propagation models. It's extremely important to deployment and spectrum efficiency. So just to give an anecdote, the propagation models we're using today, one of the ones that's built into the CBRS requirements for protecting incumbents, was developed in the 1960s by ITS. So we're using a model that is 60, going on 60 years old. That model itself was based upon empirical data that were acquired in the 1950s. And that's what was fed in to build this model that was issued in the 1960s. So the data upon which we're now protecting people in the CBRS band is based on data that were originally acquired much closer to the time of Marconi than it is to today. So the argument is we're using very antiquated propagation models that haven't been thoroughly validated, yet we're using them to create these enormous 400 kilometer in size protection zones to protect the DoD. And I think this is a good indicator, this is a good reason why we're not seeing interference complaints from the DoD, because they are so overprotected in many of these cases, there isn't a chance that we can cause interference to them. So I really think, now that we have better geodata, data on buildings and foliage and things like that, like we see in Google Maps and other map utilities, we need to leverage that. We need to build that into spectrum sharing propagation models, and we need to get back that 40 or 50 or 60 dB of additional protection that is there, but we're not accounting for it because we're using propagation models that are extremely old.
Ira, what do you have to say to that?
So, I agree. Anytime we can make some progress, it's better propagation models. I mean, we've heard this, time and time again, but we can only work with what we have. So until there are newer models that are, developed, validated, agreed upon, I don't want to say we're somewhat stuck, but on the same token, I also want to mention, that a lot of the analysis that we get at the commission when we're considering, spectrum allocations and sharing or new allocations, new rules, folks always come in often with worst case. Sharing or anytime incumbents always paint the bleakest picture. New entrants always paint the rosiest picture. And the truth usually lies probably somewhere in the middle. And I think trying to get to anything that's more realistic rather than always relying on the absolute worst case or maybe the absolute best case in that sense, but trying to get to more realistic data that comes in for us to analyze and look at things would probably greatly help the process, maybe even speed it up, if all sides are at least somewhat in agreement towards the beginning of the process, rather than always kind of being at loggerheads and and then us trying to work through those through over many months and competing studies and so forth to try to reach decisions that are going to work.
Is it possible for the PALs to enter into commercial arrangements to effectively narrow that protection zone?
Yeah, the rules are flexible in allowing private arrangements, private agreements with the, either with the SASs or I think with the PALs. There's flexible leasing rules within CBRS. So, I think, the rules built a lot of flexibility in for folks to take advantage of in order to create better, more efficiencies as things develop.
Yeah. Except for protection of DoD, there's no flexibility there. Right.
Mm-hmm.
Right, but you're also protecting a lot of fixed satellite operations, and there I think you can take advantage of a lot of flexibility.
Okay. So there was a question from the audience about third-party neutral providers, and that most of them are located in urban areas. And asking a question is, why aren't there more of them in rural areas, or is there an opportunity to bring in more competition to rural areas by facilitating the entry of neutral third parties?
So in Peru, Facebook partnered with Telefonica and had a lot of success. And in the Peru model, the regulator established mobile build-out requirements to certain areas and allowed these third parties to come in to fulfill them, and also kind of forced the licensees to come to an agreement with these third parties. And in a way, I think this was a cooperative process for the trial, but having that policy framework in place allows these opportunities to be successful, because that business might be a smaller business and might be locally based and be able to build out the infrastructure and then allow a lot of mobile network operators to, use it so that their end users can use their services anywhere, and it kind of benefits all the stakeholders.
So, and you just wondered if there's any thoughts from Google, because you have your own, I guess, Google phone system, the own MVNO system.
Yeah, I mean, I don't have any specific thoughts. I don't speak for our Fi product, but we are very active in alliances that are pushing neutral host type solutions for broadband access, because we think it is the future. Let everybody collectively involve themselves in providing the wireless connection, rather than just allowing the well-funded few to do that same thing. I think there's room for a variety of models. Obviously, the MNOs take on a lot of financial risk to build out their networks, and they're doing a good job at it. But we think as far as pushing access to individual buildings, better in-building operations, DAS replacements, and to some extent rural broadband opportunities, I think there's more room to improve and expand the neutral host model.
Okay, so maybe the last question, which is be fairly provocative then. We've seen in the last 20 years or so the wireless industry in the U.S. and as well as many other parts of the world essentially separate the tower industry from the wireless industry. And is there a reason that won't take the next step, essentially go down the road that you're talking about, Andrew alluded to, where essentially the network operator is separated from the service provider that you sign up with? Or is the world not ready for that?
Yeah, you're saying that so basically it's a network operation or just wholesale providers?
Essentially, it's what's happened with the towers, right? And then
right.
You guys are providing a lot of incremental service. What about the next step?
I'll speak personally. I mean, personally, I don't look at that as something that's happening. I think that there's too much value.
It would allow massive network sharing.
What, pardon me?
It would allow a lot of spectrum sharing.
But I actually think that there's a lot of value and innovation that actually continues to come from the commercial operators. And I think if you look at the partnerships that they're actually making, even with all these other just kind of what I would call a growing 5G wireless ecosystem, I think again we're at the tip of the iceberg for what these operators can do. And I think if you they become just a wholesale operator, they miss out on that. They miss out on revenue opportunities. And I think we, as a country or a world, we would miss out on innovation. So I don't see that happening. I mean, yeah, we saw it on towers, but if you look at the towers, the assets and how that has kind of happened over time, you can understand why that happened on the tower business. Now the tower, infrastructure folks, I can see moving closer and closer to providing more and more capabilities. But in fact, you've seen announcements on
right.
edge networks and things. But overall, personally, I don't feel like you're going to see them, the model be wholesale operated.
Yeah, I think you can make a distinction between sort of that passive infrastructure sharing that is sort of helpful everywhere, and then situations where the main challenge is really there's no investment versus there's no competition. So in a rural area, if this active sharing can make sense because it can fill a need where there's no investment, there's no natural incentives to invest, or there's no business model, versus, and you're not really missing out on that innovation. So that, I think that's where I would draw the line.
Armand, I would just add that for Viasat, we're a vertically integrated provider, and for us, that's made that's been a competitive advantage for us because we're all the way. We do fiber. We have a company that does fiber optics. We build gateways all around the world. We are now building our own satellites, and we build the end user terminals. So being in control of all those pieces has allowed us to take out all the bottlenecks and build a network that we can adjust and also provide, we think, a very, very efficient service on. So for us, it's actually going the other way. It's being a vertically integrated operator.
Okay. This has been a good discussion. I think one of the interesting things I'd like just to point out about this panel is that we have, it's dominated in a sense, three people are coming from non-traditional telecom providers to a certain extent, as opposed to the big three or the big four, which just sort of shows where some of the innovation in the industry is coming from. It's coming from some of the new entrants, whether it's the Facebook, the Googles, the satellite operators. And I'm wondering if anyone just wants to comment on that. And actually, we'll let let Chris Pearson go first.
Yeah. Well, I represent 5G Americas, and I would say as an industry association that to progress 5G throughout the Americas region, we look at this as a growing mobile wireless ecosystem. When we look at 5G, the architecture, the standard, even some of the spectrum that's being utilized, it's growing, and that's why you're seeing these partnerships. For that, people would say, well, how is that mobile wireless? How is that 5G? Well, 5G is one of the key enablers of many technologies, applications, and services, as well as it's being enabled by some of these other areas in this ecosystem. So the 5G wireless ecosystem, from a 5G America standpoint, is growing, and to have non-traditional folks that are kind of moving into this family of 5G and what it can do, I think it's a positive for the industry, and I think it's a positive for consumers and enterprises and industrial applications.
Okay, I'm told our time is up, but I think that was a great final wrap up, Chris.
Oh, thanks.
And I hope everyone enjoys the rest of the conference. And I want to thank our panelists for a terrific job.
Thank you.
Thank you, everyone. And I wanted to add my thanks to Armand there again. Thank you, guys. That was a really interesting panel. So thank you to all of our panelists. And Armand, thank you, of course, to yourself as well for moderating that so well. So really interesting discussion, guys. Thank you all so much. And that's not quite it for the day, though, because next it is now the opportunity for all of you guys out there to get involved. So in a second, I'm going to invite you all to head over to the Have Your Say area, which you'll find on the left-hand side, your left-hand menu bar. So we now have a Have Your Say session. So the way this is going to work, Armand is going to be heading over there now, and he will be moderating this session alongside Joanne LeMay, who moderated, of course, the session yesterday. So Armand and Joanne will then be inviting all of you guys out there to come live up onto the stage, to bring your audio and your video feed live, and to come and give your thoughts and your comments on the panels that we've heard so far. So the panels today, the panels yesterday, any thoughts you've had more broadly on any of the discussions so far, we want to hear from you. So this is your chance to come and do that. So as I said, please do make your way over there. So you need to click on the Have Your Say link on the left-hand side and then head into the Have Your Say room. I'll be heading over there now shortly as well. So I'll see you over there in just a couple of seconds. And in the meantime, once again, a big thank you to all of our panelists for that last session. And I hope that you guys are able to come and join us in the Have Your Say session as well. So you're more than welcome to come up and be part of that as well. So thank you, everyone, and see you over there very shortly. Thank you.